Today's episode of the Gone Fission Nuclear Report is brought to you by Fluor. We're building a better world. Welcome to the Gone Fission Nuclear Report, your one-stop source for all the latest news from the Department of Energy's Environmental Management Program. Now, here's your host, Michael Butler.
Hello and welcome to the Gone Fission Nuclear Report. Today is Monday, December 5th, 2022. We're covering all the news from the Department of Energy's Environmental Management Program across the country. We thank our friends at Fluor for being presenting sponsor for today's episode. Solidifying nuclear waste into a glass form, a process called vitrification, is currently the preferred way to prepare nuclear waste for permanent disposal. But an advocacy group in Richland, Washington, is making the case that grouting is the faster, less expensive alternative for mixed low-level waste, which comprises 90% of the tank waste stored at Hanford. Gary Peterson and Dwayne Smoker of Clean Up Hanford Now argue their position in this week's episode of the Gone Fission Nuclear Report.
If you look at the current plan for vitrifying both high-level waste and low-level waste, the life cycle cost of those two is in the range of $323 billion to over $600 billion. And the time frame goes out into the next century. But the Government Accountability Office, the National Academy of Sciences, Congress has directed a study of this, which is the FFRDC, and those reports are all recommending that grout be used in the low-level waste and can save at least 1/5 of the cost and decades in time of cleanup if you proceed.
We first talked with Gary and Dwayne in an audio podcast last spring. That episode remains one of the most popular on our audio series. We'll hear more from them later in the podcast. We'll be back with today's headlines right after this from Fluor. Cleanup of DOE sites creates thousands of tons of contaminated waste that must be properly managed and disposed of. Most sites rely on on-site disposal for handling much of the waste and debris from cleanup. In some cases, decades of cleanup have filled on-site disposal areas to their capacity, and more space is needed to finish the job. 2 DOE sites are dealing with that issue now. At Idaho, EM, EPA, and the state have agreed to expand the Idaho disposal facility. The expansion will accommodate disposal of contaminated soil, debris, and even reactor vessels for an additional 25 years. Operating since 2003, the current disposal facility has a capacity of 390,000 cubic meters, about the size of 10 football fields. Without expansion, the facility, which is now about 80% full, would reach its capacity in 2025. The new cell will increase capacity by about 1/3, with an expected operating life of about 25 years. An on-site waste disposal expansion is also planned in Oak Ridge, with construction of a new environmental management disposal facility. EM is hosting a public poster session this week to help educate the public about the benefits and safety of the new facility. The current disposal facility is nearing capacity. Expansion will be required to complete cleanup of excess facilities at Oak Ridge National Laboratory and the Y-12 plant. It was 72 years ago last Tuesday, November 29, 1950. That was the day the front pages around the country screamed the news in banner headlines. A new government plant would be constructed near Aiken, South Carolina. Its purpose? To produce plutonium for hydrogen bombs. It was big news for the central Savannah River area of South Carolina and Georgia, and would forever alter the face of the region. Towns and their residents were relocated. DuPont would build the project with a congressional appropriation totaling $260 million. What was then known as the Savannah River Plant would grow to become South Carolina's largest employer and would continue to contribute to national security through a host of missions for decades to come. And finally, another piece of nuclear history. Last Friday, December 2nd, was the 80th anniversary of the world's first self-sustaining controlled nuclear chain reaction. Known as the Chicago POW-1, the experiment took place at 3:36 p.m. in a converted squash court at the University of Chicago's abandoned Stagg Field. 49 scientists, led by Enrico Fermi, were on hand for the event. Leona Marshall was the lone female researcher in attendance. The group celebrated with a bottle of Chianti that was poured into paper cups. Most of the participants signed the wine bottle's label. This turned out to be the only written record of who had taken part in the experiment. A memorable day indeed. We'll be back with today's Spotlight interview right after this from Fluor. This week, we're reprising an interview we did with two leaders in the Hanford community last spring. This interview drew a lot of listeners in our audio series and remains the topic of intense discussion. The question: should the mixed low-level waste that comprises most of the tank waste at the Hanford site be disposed of through grouting rather than solidification in glass or vitrification? Our guests today say grouting is cheaper and faster and safe and would reduce the time needed to clean up Hanford waste by many years. Here's our interview with Gary Peterson and Dwayne Schmoker of the group Clean Up Hanford Now. We're talking today with Gary Peterson and Dwayne Schmoker. Both of these gentlemen are involved with Clean Up Hanford Now, which is a nonprofit organization that is promoting the use of grouting as a means of cleaning up tank waste faster and less expensively at the Hanford site. And we want to hear more about that today. Gentlemen, welcome to the podcast.
Well, we're
Thank
glad
you,
to be
Michael.
here.
We're very happy to have you here. Gary, you formed Clean Up Hanford Now as a nonprofit organization to promote grouting as a means of cleaning up the Hanford tanks faster and less expensively. Tell us about the organization and what its purpose is.
Well, the organization was actually formed over about a 4 or 5 year period. A few of us got together and realized that there were not many individuals in this community who really cared about trying to get Hanford cleaned up and make it usable for other purposes. Small modular reactors, carbon sequestration, manufacturing, all kinds of uses. But we can't do that as long as Hanford isn't cleaned up. And DOE itself put together a comprehensive land use plan back in the 1980s that said there is a future use of Hanford, but Hanford has to be cleaned up. So we formed this organization so we could be a spokes platform for the community for cleaning up Hanford as rapidly as possible. Let me stop for just a second. Under the current scenario, DOE is saying that Hanford won't be cleaned up until the year 2084 or as late as the year 2168. And so that's continuing down the path that they're on, which is to vitrify all the high level and low level waste. And that's if everything goes perfectly. And so we know that grout could be used on 90% of the tank waste. There's 177 tanks, 56 million gallons of waste, and about 50 million of it is mixed low-level waste that could be grouted. Cheaper, faster, recommended by the Government Accountability Office, we think it will be recommended by the National Academy of Sciences, and it certainly is supported by 4 national labs.
How about telling us what mixed low-level waste is? I think when we think of tank waste, of course, we think of high-level waste. I think that's the common perception. So about 90% of the waste in the Hanford tanks is mixed low-level waste. I think when people think about tank waste, the common perception is that it's high-level waste. So can you explain to us what mixed low-level waste is and how it compares to high-level waste?
Yes, thank you, Michael. It's an excellent question. I think there's a lot of confusion in people's minds about this. If we start back at the beginning, this waste is derived from the reprocessing of spent nuclear fuel. In the case of Hanford, the spent nuclear fuel came out of reactors and was dissolved in nitric acid to create uranium and plutonium, to extract uranium and plutonium from the used fuel for the national defense programs. In doing so, a lot of chemicals were added, a lot of process steps undergone, but the main product that the government wanted was uranium and plutonium. Everything else was considered a waste byproduct. That waste byproduct was then placed into underground storage tanks. It was very radioactive, and it was an entire witch's brew of chemicals and radionuclides and every kind of thing you could think of. But DOE has managed that waste over the years as waste, just that, waste. They manage it as high-level waste because that's very conservative, and I think that's where a lot of the confusion comes from, is it's not necessarily high-level waste, but they manage it that way just for conservatism. The facts are is that waste stream can actually be broken down into 2 constituent parts: a high-level waste stream and a mixed low-level waste stream. The low-level waste stream really consists of those materials that can be separated out and leave behind a waste stream that is very low in radioactivity, but likely high in chemical constituents, thus the term mixed low-level waste. The high-level fraction consists primarily of the radioisotopes of cesium-137, strontium-90, and some long-lived actinides such as plutonium or uranium or things like that, which under the definitions that the government has established becomes high-level waste, meaning those radioactive constituents need to be isolated from the biosphere, from humans, for long periods of time, tens of thousands of years. Whereas low-level waste loses its radioactivity in a relatively short period of time, let's say 300 years. So because vitrification and long-term deep geologic disposal is so expensive, it is very advantageous to separate the waste into two streams. And when you do that, you find that 90% of the waste can be separated into a mixed low-level waste fraction. So lots of volume, very little radioactivity, whereas the 10% stream has most of the radioactivity, a very small volume. That would go to vitrification.
Well, that's an excellent description. Thank you. Now, is it true that grouting is only appropriate for the mixed low-level waste portion and not for the high-level waste? Is that right?
That is correct. So under the law, things that to be isolated in a deep geologic repository require vitrification in borosilicate glass. So that is why at places like Savannah River Plant, the high-level waste is being placed into vitrified glass canisters. In the case of Hanford, eventually the high-level waste will go into vitrified glass canisters to someday be taken to a deep geologic repository. Today, that place is Yucca Mountain, but of course, you could do another whole podcast on just Yucca Mountain.
Or three or four. Yeah.
Or 3 or 4, exactly. But yeah, under the current law, what's on the books today, that's where it's destined, and that's where the high-level fraction goes.
Right.
The mixed low-level waste fraction can, in fact, be placed in other disposal media. At Savannah River, that is in grout, into very large grout vaults that are capture the low-level waste, and it will be stored in those vaults for about 300 years. In the case of Hanford, it's more complicated than that. And so if you do desire, you want to talk about Hanford, that brings about the Hanford story and the controversy surrounding grout.
Well, let's get into that. Grouting has been tested at Hanford over a period of time. Can you tell us a little bit about those tests and how they were conducted, how they worked out, and what's really the sticking point today in terms of using grouting rather than vitrification on the bulk of this waste?
Well, that's an excellent question, Michael, and I'll take a stab at that. And Gary, maybe you want to jump in here. But here's what it comes down to. At Hanford, there was, back in the late 80s and 90s, some testing done on grouting waste. And they designed and built some grout vaults, and it was going to follow a pattern similar to what was happening at Savannah River. The state of Washington stakeholders and regulators were concerned about at that time, the formulations for the grout and the potential for release of two specific radionuclides that really the state has consistently been concerned about. Those are Tech-99, technetium-99, and iodine-129. Now, interestingly enough, those are two isotopes that live a very long time. They have very long half-lives. The other thing about them is they are considered low-level waste, and they follow the liquid. They tend to not be in the solids, but they are dissolvable in the liquids. So the state was concerned that the grout formulations would need to lock up the Tech-99 and the iodine-129, isolated from the biosphere for a tremendously long time to prevent its leaching into the groundwater and eventually into the Columbia River. So the vitrification plant for low-level waste was principally conceived for the purposes of binding up Tech-99 and iodine-129 for long periods of time if the state was going to allow it to be buried in a shallow land disposal facility, which is what is currently planned. So that is what sparked the change from grouting to vitrification because of those two radioisotopes. And that, of course, begins the prelude to why Clean Up Hanford Now and NEA is focused so much now on grouting and moving the waste out of the state of Washington. So if you're interested in that, we can talk about that too.
Well, from what I've read, about 1/3 that grouting can create a savings of about 1/3 to 1/5 of the cost of vitrification. How do you get those savings, and what does that mean to the program if you're able to save that much money?
Well, how about I take the first part of that, and then Dwayne can leap back in. But if you look at the current plan for vitrifying both high-level waste and low-level waste, the life cycle cost of those two is in the range of $323 billion to over $600 billion. And the time frame goes out into the next century. But the Government Accountability Office, the National Academy of Sciences, Congress has directed a study of this, which is the FFRDC. And those reports are all recommending that grout be used in the low-level waste and can save at least 1/5 of the cost and decades in time of cleanup if you proceed. Let me mention one other thing. The current vitrification plan for all of the waste does not include any activity in the 200 West area currently. And so another plant similar to the high-level waste treatment plant that we've got now would have to be built to take care of the 200 West tank area. Those costs just drive the top right off. Ecology itself has pointed out in the last 7 years, there has not been a compliant budget, either requested by DOE or coming out of Congress.
And when you say ecology, you're talking about the Washington State Department of Ecology?
Washington State Department of Ecology has written reports showing that they understand that there has not been a compliant budget for the last 7 years. It's not going to change this year. And so any year that you don't have a compliant budget, the schedule goes out and the cost goes up. And so the numbers I just quoted, which is in the $300 billion to $600 billion range, those go out the window. I mean, it's already impossible to reach those. It's over that.
What makes grouting less expensive?
So it really boils down to unit operation steps. In short, the vitrification process, as you would expect when you make glass, any kind of glass, is a high temperature process. And so consequently, there are numerous numbers of safety systems, auxiliary systems, off-gas treatment systems, any number of systems that have to go with a plant that operates at very high temperatures, especially if you're processing lots of water and liquids and radioactive material. And so consequently, the vitrification process, most people think of you just put the waste in and you get glass. The fact of the matter is it doesn't work like that. You not only put the waste in, but you add thousands of pounds of glass formers, sand, silica, sugar, numbers of chemicals to make good borosilicate glass. You also add millions of gallons of additional water. Then you have to treat the off gas coming off because the off gas is very acidic. So you have to treat that, and that off gas liquid has to go somewhere. So currently, for every gallon of liquid we send into the vitrification plant, we get back on the order of 2 gallons of liquid that we have to treat and deal with. All of those unit operations, the the equipment, the systems, the permits, the people, the maintenance add to the cost of what it costs to vitrify. GAO's Government Accountability Office number is approximately a tree. Now let's talk about grout. Most of us have mixed up grout before. If you've ever put fence posts in the ground or mixed up something for your driveway, it's the addition of sand and Portland cement with water. It is not a high temperature process. You normally do it in a wheelbarrow. And it doesn't require tremendous amounts of skill or recipes or anything if you're doing it in your backyard. If you're doing it for nuclear waste, it's slightly different than that, in that now the water is actually the nuclear mixed low-level waste that you're adding. You're still adding some additives in the way of some sand and some Portland cement, mostly Portland cement, and you now convert that liquid into a solid. There very little off gas. There is no secondary liquids coming off. And so for every gallon of low-level waste you put in, a gallon of grout rock goes away. And so, as you might guess, and just thinking about making glass versus making a brick for your driveway, the number of steps and people it takes far less, thus far less expensive. GAO's number comparison is about $100 a gallon, $100 to $200 a gallon versus $1,081.
Gary, when you formed the Clean Up Hanford Now organization, what are you doing? What is the group doing right now to promote grout as an alternative?
Well, I think you know, Mike, we have met with the governor a couple times. We have met with several of the directors of the Department of Ecology. We have written op-ed pieces. We have run explanations of the benefits of grout. We have supported what is called the Test Bed Initiative, which is a demonstration project, which did manage to treat 3 gallons of waste and move it all the way to Texas, and it's in the repository in Texas. Currently, we're trying to move forward with the demonstration project of 2,000 gallons of tank waste, mixed low-level waste, and get that demonstration done so Congress can see it. We support all of those activities, and we do it politically. We do it community. We talk with the media, any avenue that we can find to advance the message, because we think it's the only answer.
Yeah.
Can I add to what
Yes.
Gary said, Michael? And if we do run out, we'll plug back in.
Okay.
Because it's a very, very important point.
Okay.
So we are not advocating at the moment for grouted waste to remain at Hanford.
Sure.
The state of Washington is very hard over on the fact that they do not want mixed low-level waste grouted and left at Hanford. It's really important, and Gary brought up the issue of the Test Bed Initiative. It's important for your listeners to know what that is. And this was really born out of something that happened in 2015. In 2015, the state of Texas and a company called Waste Control Specialist received a permit a permit modification to their low-level waste disposal site permit that allowed them to take and dispose of Tech 99 and iodine 129. They contacted me, and after a lot of, are you sure you have that? We determined that would really be the holy grail for Hanford. If you could get rid of those two radioisotopes in some place other than Hanford, near the Columbia River, near our near surface groundwater, this would be a significant step forward in advancing the cleanup mission here at Hanford. Not only would it be cheaper, but it would go to a low-level waste disposal facility that was far better from a geologic standpoint. And if you're familiar with their particular location, it's not too far from WIP, and it sits on a mountain of clay. It's just a very robust place. That's where the testbed initiative was born from, was the concept of, can we logically, technically, and so from a societal standpoint, move low-level waste from Hanford, put it into grout, ship it to Texas, and can we dispose of it in Texas? And can we demonstrate that that is faster, better, cheaper than the path we were on? That is the testbed initiative. That's what Gary referenced. It was designed in three phases. A laboratory scale, 3 gallons. We did that. We actually did that 3 years ago. The engineering scale, 2,000 gallons. We're ready today to do that test, and we could talk about what's holding that up. And then finally, a production scale, 300,000 or more gallons of mixed low-level waste. And that would then set the stage for knowing the costs, opening up the pathway, and making sure from a permitting and societal standpoint, everybody was on board with it. So that's the testbed initiative. All we're really advocating strongly for is finish the demonstration. You'll know more after the demonstration than we are right now. And quite frankly, what we're finding from a societal standpoint is the state of Washington is very much struggling with allowing this demonstration to go forward.
Gary, earlier you touched on the Department of Ecology and some of the things that are going on there relative to grouting. It seems from what I've seen that they're very supportive of the vitrification route on this. And where do you stand relative to working with them or changing their mind in terms of moving toward a grout alternative? Why is ecology, the Department of Ecology, so committed to the vitrification route and doesn't seem to be willing to give attention or the go ahead for grouting?
Okay, so let me start by saying publicly, Department of Ecology has and will continue to say they support supplemental treatment, including grout. I mean, there are other methods of supplemental treatment as well. So publicly, they have said loud and clear that they support the grouting technology. But at the same time, they gave a presentation before the National Academies of Science a week and a half ago, in which they said that vitrification is, in their mind, the best way to handle all of the Hanford waste, because they still firmly believe all tank waste is high-level waste. Now, let me just stop and make sure, Dwayne, that's what your understanding is as well.
Yeah, that is absolutely correct, Gary. They have taken a position that, despite the story that I told earlier, that it is waste managed as high-level waste and that it can be separated into its two requisite fractions, their position is it's still high-level waste, and therefore the high-level waste vitrification standard applies even to the low-level waste fraction. And their position with DOE is, if DOE doesn't want to vitrify that waste, then DOE need to seek a variance from what they believe to be the standard of high-level treatment. DOE, of course, does not agree with that position. That once you do the separation, it is no longer high-level waste by definition, and therefore DOE and ecology are in disagreement on what the waste is actually determined to be after the separation step.
Let me just point out, Mike, that there is a piece of equipment out on site called TSCR, tank size cesium removal. It has now processed, by the summer, it will have processed 1 million gallons of tank waste and taken out all of the constituents that make it anything other than mixed low-level waste.
Correct.
And the count, the radioactive count of that volume is so low that you could carry around a liter of it for weeks, months, and not get any more radiation than you would if you flew from Seattle to New York. I mean, it is truly low-level waste, and it's processed. It's waiting to go for the demonstration of the test bed initiative.
This is an aside in a way, but how does this fit in with DOE's current deliberations on the definition of high-level waste? I assume it's related, right? I mean, talking about the same topic.
Dwayne?
Yeah, it's the same topic, but it's approached differently. So in the case of Hanford, DOE has given assurances to the state of Washington that at least in the near term, they will not use the so-called high-level waste definition as a method to determine if waste is high-level or low-level or not. Instead, what DOE has said is they will follow the process which is known as a WIR determination. WIR, W-I-R, stands for Waste Incidental to Reprocessing. That is a methodology and approach subscribed to by the Nuclear Regulatory Commission, where you sample waste before treatment, you sample waste after treatment, and you demonstrate that you have removed the radioactivity constituents of concern. In this case, it is the cesium-137 and any actinide material solids that might have been floating in the liquids, that you remove that, you sample it afterwards, you do a very thorough laboratory analysis, and then DOE makes a determination based on the sample after treatment that it is in fact waste incidental to reprocessing. At that point, DOE then can determine that waste to be mixed low-level waste. That is the process that they will and have planned to follow at Hanford. The waste determination process is essentially the same process, except it removes the WIR determination and allows DOE to make the unilateral determination that in fact waste is mixed low-level waste. That has been a difficult issue for the state of Washington that really doesn't go to this waste as much as it does for the closure of waste inside of tanks, the residuals that are left in tanks. And the state's position is they're not ready to accept DOE's ability to just say that's low-level waste left in the tanks. So they're related, but for purposes of cleaning up Hanford in the near term, there are processes DOE can use and in fact are pursuing as we speak. They've already done a WIR working on a WIR determination for the testbed initiative. They're working on a WIR determination for the vitrification of the low-level waste also.
Finally, the last question I have for you, Gary, I've read that part of the mission of your organization, Clean Up Hanford Now, is supporting new missions for the Hanford site. And I guess part of the urgency or the the need to get the tank waste cleaned up sooner through grouting, as you're proposing, is to be able to get some of this land into redevelopment and reindustrialization so you can create some new missions on the site. Can you talk about that a little bit?
Certainly can. Let me just start, Mike, by saying if you can reduce the costs of cleaning up that tank waste down to 1/5 what is expected currently, that also frees up money for investment by DOE in new technologies, energy technologies that could be located in Hanford. So, I mean, they are not just connected with the land use, but they're also connected with the possibility of DOE doing what it is designed to do, which is set an energy policy for the United States and Pacific Northwest. So we have worked for a long time. Matter of fact, at TRIDEC, we had 2 different studies of the property, including the old FFTF site, which you're familiar with, and the use of those or Energy Northwest WNP1 site to do small modular reactors or testing for new nuclear plant designs, whether it's NuScale or any other design. The site is perfect for energy use, new plants, carbon sequestration, hydrogen production. You could do solar testing. You could do wind test. I mean, it is open for all of those kinds of things. You certainly wouldn't want to use the land for agricultural purposes, but you would want to use it for industrial purposes. So we see the two as being inextricably linked, and pretty exciting, as a matter of fact, because almost on a monthly basis or every other couple months, we get inquiries from companies that are interested in locating something at the Hanford site. And just in today's paper, there's an announcement of a 3,000-acre solar farm located out on the northwest edge of, it's not on Hanford, but it's on the northwest edge of this area called the Inland Empire. But those kind of things could take place anywhere across the Hanford site. So we think it's exciting, and we think that we have a purpose. I'll close by saying DOE at one point did as well, because they did what is called the Comprehensive Land Use Plan. And that was developed in the 1980s, finally issued in 1989. The very thick document that was agreed to it involved all of the communities, elected officials, Native Americans, everybody looking at what would be the future uses of this site. And energy was definitely one of those. And the entire report says Hanford should have beneficial use in the future. So to me, it's a natural.
Well, Gary Peterson and Dwayne Smoker, you guys are passionate advocates for your site and your community, and you've got some things going on there that I think are going to make a difference in the way the future unfolds for cleanup of the Hanford site. So thank you very much for being with us today on the Gone Fishing Nuclear Report podcast. We appreciate you being here, and I'm sure our listeners have gotten a lot out of this conversation today.
Today's episode of the Gone Fission Nuclear Report is brought to you by Fluor. We're building a better world.